Ever wonder how AI decides what information matters most? It's not just about having data, it's about choosing the right data. Today, we're diving into a groundbreaking approach called SEFA, Stochastic Encodings for Active Feature Acquisition, a method that helps machines learn faster by focusing on the most useful clues. Let's break it down. Imagine you're a detective trying to solve a mystery. You've got a stack of clues, but sifting through every single one would take forever. What if you could pick the most promising leads first? That's exactly what SEFA does, except instead of fingerprints and alibis, it's analyzing data. Traditional methods like Conditional Mutual Information, CMI, try to rank features by their usefulness, but they're myopic. They focus on immediate gains, like picking the next test that seems most urgent. It's like solving a puzzle by only looking at one piece at a time, missing how the pieces fit together. Then there's reinforcement learning, RL, where an AI learns by trial and error. Think of it as teaching a robot to walk by randomly poking it. It's powerful but slow, unstable, and often misses the bigger picture. Enter SEFA, a smarter way to pick data without the headaches of RL or the blind spots of CMI. How does it work? Let's get technical. SEFA starts by creating a latent space, a simplified mental map where the AI focuses only on the most relevant clues. Instead of getting lost in the noise of every feature, it reasons about possibilities in this cleaner space. Think of it like a detective narrowing down suspects by focusing on the strongest leads, not every random detail. But here's the twist. SEFA uses stochastic encoders, which means it considers multiple possible outcomes at once. It's like flipping a coin to guess what might happen next. By exploring these possibilities, the model avoids greedy choices and makes decisions that pay off later, not just immediately. To test this, researchers pitted SEFA against other methods like opportunistic RL and DIME. They used both synthetic datasets, like a simulated maze, and real-world challenges, including cancer patient records and financial risk models. The goal? See which system could find the right answers fastest, especially when data was noisy or incomplete. Here's what they found. SEFA outperformed others, especially in tricky situations. For example, in healthcare, it could prioritize the most relevant tests for diagnosing diseases, cutting down time and costs. In finance, it might flag key risk factors without getting lost in endless spreadsheets. And in particle physics, where data is massive and expensive to collect, SEFA's smart choices could save years of work. One experiment used cancer data from the TCGA database. SEFA didn't just guess. It learned which genes were most predictive, even uncovering hidden patterns that traditional methods missed. It's like finding a needle in a haystack by first narrowing down where the haystack is. What makes SEFA special? Its use of stochastic encodings, a way to represent features as probability distributions. For continuous data, we use a copula transformation to make it act like a normal distribution, simplifying learning. For categorical data, we use embeddings, like a dictionary that turns words into numbers. This allows SEFA to balance exploration and exploitation, dynamically deciding which features, like blood pressure or genetic markers, to look at next based on what it's learned so far. Even the best models need fine-tuning. That's where hyperparameters come in, like recipe ingredients. Change the salt and the dish tastes different. Researchers tested dozens of configurations for 8 models, adjusting settings like learning rates and batch sizes. For example, one version of DIME used a tiny learning rate, 0.0005 for precision, while another went faster, 0.001 for speed. It's a balancing act. So why does this matter? SEFA shows that smart learning isn't about how much data you have, it's about how you use it. By giving machines the tools to choose their clues, we're building systems that adapt, innovate, and solve problems faster. Thanks for watching. If you want to see how SEFA works in action, hit subscribe. And drop a comment. What's one area you'd love to see this tech revolutionize? Let's keep the conversation going. Stay curious, and we'll see you next time.